Let's talk about exceptions. So typically error checking code is tangled with the code that provides normal functionality. So let's look at some example code here. So let's pretend we're in some class here and we have this method called foo, which takes this integer called num. And almost all of the time we're gonna take 100 and divide it by num and we're gonna be fine. Right? So however, there is a small chance that the value 0 could be passed in for num, and we wouldn't want to divide by that. So now the question is, well, what do we do if somebody does pass in a 0 for the value of num? Okay, so we could protect this code by wrapping the division inside this if and having this else. Okay, so we call this the rainy day scenario. Okay, so we can't divide by 0, so what are we going to do? Well, we could do one of many things. We could kill the program. And again, if this is like a desktop application like Microsoft Word or something, that might not be a big deal. That might be a good solution. But if this is code that's controlling a pacemaker, that maybe is not the best thing to do. We could print an error message. Again, if it's a desktop application, that might be a good thing to do. Pacemaker, not so good of an idea. We could prompt for a new value. Again, desktop okay, pacemaker not okay. Or, we could come up with probably half a dozen other things we might want to do too. Or, we might just not know what to do, right? Because this foo might be part of some library, just like the string class is part of a library. And the people who invented the string class, they couldn't have imagined every single possible thing that could go wrong in a program. So when something bad happens with a string, we don't really know, is it okay to kill the program or print an error message? It really should be left to someone who's using the class to make that decision. Another problem with this code is it really breaks up the normal flow of what happens 99.9% of the time. The value that gets passed in is not going to be 0. Okay, so if we could remove this error checking code, the code would certainly be easier to read, because again, it we're occupying a lot of screen space with stuff that we don't really have to worry about that often, although occasionally we have to worry about it. The code will also be easier to write, especially in cases when you don't really know what you should do, like the case with the string, for example. Something bad happens with a string. Is it really okay to kill the program? Well, we don't really know. It's really dependent on who's calling the method. So an exception is an indication that something went wrong in your code. Now, traditional error handling techniques may involve having this function return a true or a false value from the method. So we might be able to clean this method up a little bit if we have instead of it being a void method, it returns a true or a false. And then we leave it up to the caller to decide if the call was successful or not. Okay, so let's imagine we had this stack class that was a fixed size, and we know that we push and pop from a stack. And let's say the push method returned true if everything went okay, and false if the stack was full when we tried to push an item onto it. Okay, so here we're no longer handling the error in the code, in the push code anyway. We're kind of saying, when you come back from this call, the person making the call has to handle it. Okay, so we've kind of pushed the problem out of the library code, and now it's in our code. This is still, though, pretty hard to read. And really, from my experience, what people tend to do is not do this, right? And instead just assume everything's going to be okay. So they write the code, the exact same call to push, but they don't even check the return value. Okay, so Java's exception handling allows programmers to handle exceptional cases outside the normal flow. Okay, and you can defer exceptional cases until later, or let someone else handle them altogether. And the exception class represents mild error conditions that your programs might encounter. So rather than terminating the program, you can write code to handle the exceptions, and perhaps even sometimes continue on with normal processing. So for example, if you try and open a file from your code, but the file can't be found, instead of killing the program, you could throw this exception and have it handled somewhere by bringing up a dialog box to choose a different file. Okay, to throw an exception, all you do is you create an object, an exception object, and use the keyword throw. So here's an example of this certain type of exception called an array index out of bounds exception. This happens whenever you go outside the bounds of an array or an array list. This exception gets thrown. So if we were writing our own list, we might throw this exception like this. So the call to new says create the object, and this calls the constructor, and then we're just throwing it. That means somebody take care of this exception. Now sometimes the JVM throws exceptions. Sometimes they're thrown by library methods, like I mentioned the array list might throw this, and sometimes we will throw exceptions. Okay, so let's look at an example of what happens when an exception gets thrown. So here's some code that is going to print exactly 3 arguments to the screen. Remember, the arguments are passed into main. Whenever you start the JVM, you have this opportunity to pass some data into the function. Well, main calls print args, and print args does something exactly 3 times. Okay, it just prints out the stuff at the command line. Okay, so I have this pre-compiled here. Okay, so if we do everything right, okay, so I'm going to invoke the JVM. This is the class with main, and then these are the 3 arguments. Okay. You'll see that, yeah, everything works right. It printed 1, 2, and 3 each on its own line. That's exactly what the print args method was supposed to do. However, if I don't pass in 3 arguments, okay, so here I'm passing no arguments in, you'll see that we have this exception. It's called an array index out of bounds exception, and since I didn't handle it anywhere, the exception was thrown, and when an exception is thrown but not handled, eventually the program just ends and we get this, this is called a stack trace. And this tells me exactly where the exception occurred. So I know it's exception test1.java line 15. So here's exception test1 line 15. And I know I got to this function from main on line 6. And it tells me that too. Okay, so this is your call stack. So we've talked about call stacks before. This is how the JVM keeps track of function calls and function returns. And when you throw an exception and nobody handles it, the program ends and we get this stack trace. So you could see exactly what type of exception happened and where it happened and how you got there. Okay, so how do we handle an exception? Well, we handle an exception with these things called try-catch blocks. Okay, so these are blocks of code preceded by the words try and catch. And in a try block, you may or may not throw an exception. Okay, if so, if an exception is thrown in this block, the flow of control is going to jump down to a corresponding catch block. Okay, but the flow never jumps back to the try block. So it's after this point, the flow falls right outside the catch block, and we go on with our normal sequential flow. Right, so in this case, we might wrap our division in this try catch, and here we could do something. We could handle the exception. So this isn't a whole lot better than what we had before. Right? Before we had an if and else. Now we have a try and catch. The real power of exceptions is that we can throw the exception and let somebody else handle them altogether. I'll show you how to do that in a second. Okay, but first let's go back to this is exception test 2. This basically does something very similar to the first program, where it's going to march through and try and print all three arguments. And now what we did is we wrapped this code in a try-catch block. So now when we go outside the bounds of the array here, the array index out of bounds exception will be thrown, and the flow of control will jump down here, and we'll print this message, please enter the correct number of command line args next time. Okay, because I didn't pass any arguments, when I tried to go to the args array at position 0, it threw this exception. Okay. But this time, what I did was I caught that exception. Okay, and we'll find out in a second we can have many catch blocks, and we always specify a type of exception. And based on the type of the exception, that's what catch block is going to be executed. Okay, so there are different types of exceptions. So there's this class called throwable. This, of course, has at least some classes above it. Perhaps the object class is directly above it. But then we have derived classes. We have one called exception. And another class called an error. Okay, the error class defines serious errors that cannot be recovered from. So typical types of errors might be virtual memory errors, out-of-memory error, stack overflow. These are things where you really cannot recover. There's no good way to recover from running out of memory. Okay, the exception class, though, is used for things you perhaps can recover from. And you can and should inherit from the exception class to make your own exception types. Okay, so I might declare this type called Mark's exception. Exception classes can have constructors, they can have data, they can have methods. They're basically plain old Java classes that happen to inherit from the exception. Okay. And the exception class has two important methods. There's one called getMessage, and this returns a string that's set in the exception class constructor. I'll have a more complete example in a second where you'll see that when you create an exception object, you can always pass in a string to give a little error message about what's happening at the time the exception occurred. And print stack trace. This will print the call stack and show where the exception occurred with line numbers, with file names, and show the flow of function calls and how you got there. So we saw that a second ago when the array index out of bounds exception was thrown. If nobody catches it, by default, the program ends and we have this stack trace printed. If an exception occurs within a try block, all catch blocks will be searched from the topmost catch block to the bottommost catch block for a matching exception type. Now, since all exception classes inherit from another class, the inheritance hierarchy is important. Okay, the first catch block with a matching exception type, remember inheritance is the is-a relationship. Okay, the first catch block that matches will handle the exception. So what you wouldn't want to do is, if you're going to have multiple catch blocks, right, you would never want to put the plain old exception first, right, because Mark's exception is an exception because it inherits from it. And we'll never get here. Why? Because even if a marks exception is thrown here, these catch blocks are checked in order. And we basically ask, is marks exception, does it match this type? Well, technically it does, because marks exception is an exception. It inherits from the exception class. So we'd want to put the most specific exception types at the top and the more generic exception types towards the bottom. Okay, so the order does matter, the order of the catch blocks. Okay, Java has this rule called the handle or declare rule. So Java's exception mechanism has this rule that says the compiler will force you to catch a thrown exception in the same method, or declare in the method heading that the exception is going to be thrown. So let me give you an example here. Okay, so let's pretend we're in this foo method and something exceptionally bad happens. Okay, so here's a great example of, kind of throwing up your hands and saying, I don't really know what to do at this level. So I'm going to throw an exception, but I'm not going to catch it in this code because we don't really know what is the right thing to do right now. Now, the method must let it be known that an exception can be thrown from this code, and we do that up here in the function header with the throws marks exception. So what this says is this is a void function called foo that may throw this exception called marks exception. Okay, and declaring it like this makes it so that in the Java doc, someone calling your method will know that there's the possibility that this might happen. Okay, there's one exception to the handle or declare rule, and the exception has to do with any class that inherits from one called runtime exception. Runtime exceptions are basically too dumb to check for. So there's the special exception called runtime exception. Okay, and there are some subclasses of runtime exception. So index out of bounds, for example. Inherits from runtime exception. And this makes sense because if you remember the first example here, I have this method that clearly an exception was thrown in here, the out of bounds exception, but I didn't have to say this throws out of bounds exception. That's because this is one of those special cases where the array index out of bounds exception inherits from runtime exception, and runtime exceptions are the one variation on the handle or declare rule. Let's see, there are a few others. Arithmetic exception, right, if you divide by 0. Null pointer exception, so if you ever use a reference before it points to an actual object. Okay, so none of these exceptions have to be declared to be thrown because, again, they inherit from this runtime exception class. Okay, so let's look at a slightly bigger example here, and I'm going to show you some code that implements a very simple stack. So we remember a stack is a last in, first out container. This is going to be an array-based stack. So all of the items are going to be stored in this array of object references. So remember, in Java, in our data structures, we don't typically hold objects, we hold pointers to objects. Okay. And we have this constructor where we're going to create some number of these object references, and we have the top of the stack and the number of elements. You should remember this from data structures. And basically, two bad things can happen with an array-based stack. We can either push on a stack that's full, or pop from a stack that's empty. So in the push method, we see that we do this check, is it full? If not, then we add to the top of the stack. But if the stack is full, we throw this exception called a stack overflow exception. And if we go, this is a class I wrote, it's called stack overflow. It extends the exception class. Okay. And a lot of times your exception classes will look just like this, where they don't really do much except extend exception and maybe have a constructor so that when you do create a stack overflow exception, you can pass in a string that describes kind of what's happening. And the base class, exception class, it has a constructor that takes a string, so you could call super s. And now, if you do have an exception object and you call get message, then that's the string that you'll see. We also have a stack underflow exception. Okay, very similar. Okay, so here since we throw the stack overflow exception in some cases, we need to declare the fact that this method might throw this exception, and we do that with the throws keyword up here. And then here's the string, so we can give a little bit of context information. We had an error pushing this value O. Pop works very similar. If the stack is not empty, we'll pop from it, but if it is empty, we're going to throw the stack underflow exception. And then in the driver, what we can do, we create a stack and make it exactly 3 elements large. We start doing some pushing. Okay, so we push 1, 2, and 3, and then we pop 3 times. So let me recompile the driver. Run the driver, and let's see here. Did I save? Let me try that again. There, I didn't save. So we push 1, 2, 3, and we pop 3, 2, 1. That's typical stack behavior. But now if let me push the 4th element on this 3-element stack, and we should get a stack overflow exception. Okay. So in the driver, I have this catch block that specifically looks for stack overflows, and here I say system.out.println the object. I could also have said get message. I think by default it does grab the message. And yeah, let me run this. So error pushing 4. Let me comment that one out. And now I'm going to pop an empty stack. So we push 3 things, and here is going to be my 4th pop. Again, that's in a try catch block. So once the stack underflow exception has been thrown, flow of control should jump here. And here's where I'm calling the print stack trace. And we should see exactly how we got to this point. So we got here from stack.pop, that's where the exception was thrown on line 76. Okay, and we got there from the main stack driver, line 28. there. Okay, so this is actually a really nice way to kind of defer your exceptional cases till later. So we've actually we're not handling them at all really in the stack class. We just say when something bad happens, we're going to throw an exception and let somebody else deal with it. And then, the way we deal with it is we handle the sunny day scenario here all in one nice readable block. And then if anything bad happens, we can catch those exceptions and deal with it down below.